Hello genius people. Today I'm going to discuss about MCQ number 16. This problem belongs to polarization topic from Wave Optics chapter Standard 12 Gujarat board textbook. And here they say that a ray of light is falling on a glass and the glass has got refractive index 1.54. Now this is of course an unpolarized light. And we do know that from reflection, the light sometimes becomes polarized. So the reflected light may or may not be polarized. Yes, but if this angle is equal to the Brewster's angle, that is theta p, then and only then the reflected light is fully polarized. Now this reflected light is passed through a Nicol prism. Nicol prism, or instead you can also consider this as polarizer. We know that if I turn the polarizer from 0 to 360 degree, and if this is a polarized light, then the light coming out will become 2 times maximum and 2 times 0. And if you are still not understanding, I have a small animation for you. So if this reflected light is polarized, then and only then this D option would be correct, right? And I want to check that whether this is polarized light or not. So for that, this angle should be angle of polarization theta p, and as per the diagram, the angle is 57 degree. Now I want to check whether this is the angle of polarization or not. So if it is not the angle of polarization, then this light will be an unpolarized light. But if this angle is exactly theta p, which is the angle of polarization, then this light will be fully polarized. And then this would be the correct answer. So what am I going to do is I am going to apply the Brewster's law, that is tan of theta p is equal to refractive index of glass with respect to air, that is 1.54. So theta p is equal to tan inverse 1.54, and I have got this natural tangent ready for you. So I am just supposed to find out the value of 1.5 for tan inverse. So 1.5 appears to be somewhere over here. 1.54 is this value. So it is 57.1 degree, but I am just going to consider this as 57 degree. So the value of theta p is 57 degree, yes, and this is the angle of polarization. So this apparatus is set at the angle of polarization, so this light is fully polarized. And when a fully polarized light passes through a polarizer, and if we rotate the polarizer from 0 to 360, 2 times maximum and 2 times minimum intensity we get. So let us consider this situation. See over here, say this one is, this is the optic axis and this vector is parallel, so it is going to come to the screen, and the theta is 0 degree. The theta is the angle between the this axis as well as the polarizing vector, or this polarized light. So this polarized light, when it passes, it is going to come on the screen. So we get 1 time intensity on the screen at 0 degree. Suppose this is end 1 and this is end 2. Now what am I going to do? I am going to turn this by 90 degree. So the end, so this end 1 is now over here, which was earlier over here. So I have turned this end 1 by 90 degree. So the optic axis is like this and the vector is like this. So I will not get any light over here. So now 1 time dark light or 1 time dark screen happens. Correct. Still I am moving it. So this is by 90 degree. If I move this, then the end 1 comes down and end 2 stays at the top. So end 1 was earlier over here. So I have turned the entire polarizer by 180 degree. So now again the light will be able to pass for 180 degree. So I get second time bright light, right? Or if I don't count the first one, this is at 0 degree. And if I don't count the first one, then this will be first time. Correct. So I am not counting the first one. So this is first time intensity. Again, this is at 270 degree, and where is end 1? So the end 1 now is over here, which was over here. So I have turned it by 270 degree, and you can see for yourself that the vector is not going to come out because optic axis and vector are perpendicular, no light. And at 360 degree again, this is turning back, and the end 1 reaches at the same point by traveling 360 degrees, and again the light is going to come out. So I get second time maximum light on the screen. So if I turn the polarizer by 360 degrees, then the polarized light will fall on the screen 2 times and it will be absent on the screen 2 times. So this is what is happening over here, people. So if this is fully polarized and if I rotate it, then gradually decreases, becomes 0, and then again increases, but this is going to happen twice. So that's why this is the answer. So hopefully guys, you have enjoyed the explanation. Any doubts, please do comment in the comment section. Thank you for watching.